all know a guy who only occasionally shaves for big occasions, and it's because that occasional shave really hurts. It's the time of year for big occasions, and yet there he is, suffering with that cheap drugstore razor. Let's help him out. Henson Shaving's line of razors, built with aerospace precision, deliver a smooth shave your dad, brother, and even son can enjoy, eventually. With replacement blades just 10 cents each, you'll buy it once and they'll use it for life. How's that for the perfect gift? Celebrate with 100 free blades on your first purchase, and no subscription headaches. HensonShaving.com/holiday.
Feel the whoa with Listerine at BJ's. You can save $2.50 now on Listerine products like Total Care Anti-Cavity Fluoride Fresh Mint Mouthwash or Cool Mint Pocket Packs Fresh Breath Strips at your nearest BJ's location. Experience the feeling of a million germs zapped in seconds with Listerine. Discount available through December 24th. Save now only at BJ's.
This is SpaceTime Series 26, Episode 54, for broadcast on the 5th of May, 2023. Coming up on SpaceTime, changing our view of the nature of dark matter, Europe's integral spacecraft safe at last, and Rocket Lab's new Electron sounding rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims that ultra-lightweight particles based on the hypothetical axion acting in waves could provide the answer to the long-standing mystery of dark matter. It's a disturbing fact that most of the matter in the universe, amounting to a staggering 85% by mass, cannot be observed and consists of particles not accounted for by the standard model of particle physics, the foundation stone upon which science's understanding of the universe is based. What that means is that everything we see in the universe, from the largest galaxies and stars through to planets, asteroids, moons, right down to the Earth, people, houses, cars, trees, dogs and cats, make up only 15% of the total mass of the universe. And for a scientist, that's really disturbing. As for the other 85%, scientists refer to it as dark matter. They know it exists because they can see its gravitational influence on the things we can see. Without dark matter, galaxies would fling apart as they rotate. But as to what dark matter is, well, that's the mystery. For us, it's invisible. Mysteries are something scientists like to solve. So finding the particle that makes up dark matter is an urgent problem in modern physics. Not only would it solve many problems in our current understanding of the universe, but it would also provide a glimpse into a realm of new physics beyond the standard model. And that is intriguing. While some theoretical models propose the existence of ultramassive subatomic particles as a possible candidate for dark matter, others suggest ultra-lightweight particles. Now, a report in the journal Nature Astronomy has provided the most direct evidence yet that dark matter does not constitute ultramassive particles, but instead comprises particles so light that they travel through space in waves. Now, if correct, this work could resolve an outstanding problem in astrophysics, first raised 2 decades ago. Problem was, why do models that adopt ultramassive dark matter particles fail to correctly predict the observational position and brightnesses of multiple images of the same galaxy created through gravitational lensing? We know dark matter does not emit, absorb, or reflect light, which makes it difficult to observe using traditional astronomical techniques. Today, the most powerful tool scientists have for studying dark matter is through gravitational lensing, the phenomenon first predicted by Albert Einstein in his theory of general relativity. Now, in this theory, mass causes space-time to curve, and that creates the appearance that light bends around massive objects, such as stars, galaxies, or groups of galaxies. Now, that bending light acts like a lens, allowing you to see clearly more distant objects. It's an important astronomical tool. And conversely, by observing this bending of light, astronomers can infer the presence and distribution of dark matter. Now, in gravitational lensing, when the foreground lensing object and the background lensed object, both constituting individual galaxies, are closely aligned, multiple images of the same background object can be seen in the sky. But the positions and brightnesses of the multiply lensed images all depends on the distribution of dark matter in the foreground lensing object, thus providing an especially powerful probe of dark matter. Back in the 1970s, hypothetical particles referred to as weakly interacting massive particles, or WIMPs, were proposed as the most likely candidates for dark matter. Now, the WIMPs were thought to be ultramassive, that is more than at least 10 times as massive as a proton, and that they interact only with matter through the weak nuclear force. The particles emerged from supersymmetry theories, which were developed to fill deficiencies in the standard model. However, over the past 2 decades, adapting ultramassive particles for dark matter have left astrophysicists struggling to correctly reproduce the positions and brightnesses of multi-lensed images. In these studies, the density of dark matter is assumed to decrease smoothly outwards from the centers of galaxies, in accordance with theoretical simulations employing ultramassive particles. Beginning also in the 1970s, but in dramatic contrast to WIMPs, versions of theories that seek to rectify deficiencies in the standard model, or those, such as string theory, which seek to unify the 4 fundamental forces of nature, meaning the 3 in the standard model, the strong and weak nuclear forces and the electromagnetic force, along with gravity, have been advocating the existence of ultralight particles. Referred to as Axions, these hypothetical particles are predicted to be far less massive than even the lightest particles in the standard model, and therefore constitute an alternative candidate to dark matter. Now, according to the theory of quantum mechanics, ultralight particles travel through space in waves, interfering with each other in such large numbers as to create random fluctuations in density. These random density fluctuations in dark matter give rise to, well, I guess you'd call them crinkles in space-time for the dark matter surrounding galaxies. Now, you'd expect that different patterns of space-time around galaxies, depending on whether dark matter constitute ultramassive or ultralight particles, in other words, smooth or wrinkly, ought to give rise to different positions and brightnesses for multiply lensed objects of background galaxies. The new work, led by Alfred Amerith from the University of Hong Kong, has calculated how gravitationally lensed images generated by galaxies incorporating ultralight dark matter particles would differ from those incorporating ultramassive dark matter particles. Their research has shown that the general level of disagreement found between the observed and predicted positions, as well as the brightnesses of multiply lensed images generated by models incorporating ultramassive dark matter, can be resolved if you simply adapt models incorporating ultralight dark matter particles. And they also show that models incorporating ultralight dark matter particles can reproduce the observed positions and brightnesses of multiply lensed galaxy images. Now, this is an important achievement, revealing the crinkly rather than smooth nature of space-time around galaxies. The possibility that dark matter does not comprise ultramassive particles also alleviates other problems in both laboratory experiments and astronomical observations. You see, laboratory experiments have been unsuccessful in finding WIMPs, the long-favoured candidate for dark matter. These experiments are now in their final stretch. They'll culminate with the planned Darwin experiment, and that will leave WIMPs with no place to hide if they're not found. Also, if dark matter comprises ultramassive particles, then according to cosmological simulations, there should be hundreds of satellite galaxies surrounding our Milky Way galaxy. However, despite intensive searches, only 50 or so satellite galaxies have ever been discovered around the Milky Way. On the other hand, if dark matter comprises ultralight particles instead, then the theory of quantum mechanics predicts that galaxies below a certain mass simply can't form owing to the wave interference of these particles, which would explain why there are so few satellite galaxies around the Milky Way. The study's authors say that incorporating ultralight rather than ultramassive particles for dark matter resolves several long outstanding problems simultaneously, both in particle physics and in astrophysics. It's an interesting and fascinating prospect. This is SpaceTime. Still to come, the European Space Agency's integral spacecraft now safe, and Rocket Lab's developed a new version of their Electron rocket specially for use in hypersonic experiments. All that and more still to come on SpaceTime. The European Space Agency's integral spacecraft is safe at last, following an extended series of fixes developed by mission managers. The Integral Space Observatory was designed to study some of the universe's most energetic events, things like gamma-ray bursts, black holes and supernovae. But in 2020, the probe's thrusters suddenly failed. Now, to keep the mission alive, ESA's developed a new series of specialized maneuvers to continue flying the spacecraft using only its reaction wheels. These are rotating gyrodynes inside the satellite that allow it to store and use angular momentum to change its orientation. However, the spacecraft's original safe mode system, which activates to switch off scientific instruments and rotate the spacecraft so that its solar arrays always face the sun, relied on the thrusters to spin the spacecraft safely in the event of an emergency. This safe mode was triggered a year later when a charged particle struck a sensitive part of Integral's electronics, disabling one of its reaction wheels and causing the spacecraft to spin away from the sun. Mission managers were able to override the issue and rescue the spacecraft, but it's left the probe without a safe mode. So now Integral's team have developed a new workaround in which newly uploaded algorithms determine the best way for the reaction wheels to operate in order to maneuver the spacecraft during safe mode. This is SpaceTime. Still to come, Rocket Lab's new Electron sounding rocket variation. And we explore the constellation Scorpio, the spectacular M6 and M7 open star clusters, and the Eta-Aquarids meteor shower produced by Halley's Comet in the May edition of Skywatch. Rocket Labs developed a modified version of its highly successful Electron orbital launch vehicle specifically designed for suborbital hypersonic test flights. The company's been selected to provide hypersonic launch services under a Multi-Service Advanced Capability Testbed or MACTB project, which was awarded by the United States Naval Surface Warfare Center on behalf of the U.S. Department of Defense and the Defense Innovation Unit's Hypersonic and High Cadence Testing Capabilities or HICAP program. The new modified version of the Electron, to be called the HASTE, or Hypersonic Accelerator Suborbital Test Electron, will launch from the company's new Wallops Island Flight Facility complex on the Virginian mid-Atlantic coast. HASTE uses the same carbon composite structure and 3D printed Rutherford engines as the Electron, but with a modified kick stage for hypersonic payload deployment, a larger 700 kilogram payload capacity, and custom payload fairings to accommodate larger platforms. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for the month of May on Skywatch. May is the 5th month of the year in both the Julian and Gregorian calendars. The month was named for the Greek goddess Maya, who was identified with the Roman-era goddess of fertility Bonadia, whose festival was held in May. But I guess more importantly for many of our listeners, May typically marks the start of summer vacation season in the United States and Canada. Let's start our tour of the night skies by looking east, where you'll see the constellation Scorpius the Scorpion. In Greek mythology, the constellation was named after Scorpius, who was sent to Earth by the goddess Gaia in order to slay Orion the Hunter, after he boasted that he could kill all the animals on Earth. Scorpius stung Orion in the shoulder, but Orion's life was spared by Ophiuchus the Healer, and it was placed in the heavens along with Scorpius, who continues to pursue him for eternity. Orion the Hunter has become the hunted forever, with Scorpius rising in the east this time of year to triumphantly chase and defeat Orion, who sets in the west. Meanwhile, Ophiuchus the Healer rises in the east following behind Scorpius to chase and crush him into the earth as the Scorpion sets in the west. And so, this ancient story continues to play out in the heavens year after year. Interestingly, parts of this story predate the Greeks, with Orion known in ancient Egypt as Osiris, the god of the underworld and of regeneration. The brightest star in Scorpius is Alpha Scorpii or Antares, the Scorpion's heart. In ancient Greece, Antares' name means the equal of Mars, the god of war. That's because its golden-orange appearance is very similar to that of the red planet, and also because it passes very close to Mars every 780 Earth days. Easily seen with the unaided eye, Antares is some 550 light-years away. But it looks so bright because it's around 57,500 times as luminous as the Sun, and is one of the largest known stars in the universe. Antares is a red supergiant, about 18 times the mass and 883 times the diameter of the Sun. Were it placed where the Sun is in our solar system, it would engulf all the terrestrial planets, Mercury, Venus, Earth and Mars, and its visible surface would extend almost as far out as Jupiter. A light year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Astronomers believe Antares began life around 12 million years ago as a spectral type O or B blue star. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in. Then there's spectral type K orange stars, and the coolest and least massive stars are known as spectral type M red stars. Each spectral classification system can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then you add a Roman numeral to represent luminosity. So put it all together and you can describe our Sun as being a G2V or G25 yellow dwarf star, one of millions spread across our galaxy. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Like the similar-sized red giant Betelgeuse in the constellation Orion, Antares will almost certainly end its life as a spectacular Type II or core collapse supernova, probably sometime within the next 100,000 years or so. When it does explode, it'll appear as bright as the full moon for several months on end, and will be clearly visible during daylight hours here on Earth. Antares has a companion star, Antares B, located between 224 and 529 astronomical units away from the primary. An astronomical unit is the average distance between the Earth and the Sun, which is about 150 million kilometres or 8.3 light minutes. Spectral analysis of Antares B indicates it's pulling a lot of material off its bloated red supergiant companion. Located near Antares is the M4 globular cluster. Globular clusters are tight balls densely packed with thousands to millions of stars, which were either all originally formed at the same time from the collapse of the same molecular gas and dust cloud, or alternatively their galactic centres, the remains of ancient galaxies that have been merged into the Milky Way galaxy over billions of years. M4 is composed of 1 million or so stars originally born some 12 billion years ago. The M4 globular cluster is located some 7,200 light-years away, making it one of the nearest globular clusters to Earth. Easily seen through a pair of small binoculars, it covers an area of the sky, as seen from Earth, as big as the full moon. Astronomers estimate there are some 150 or so globular clusters orbiting in the halo of the Milky Way. Located near the tail of the Scorpion are 2 open star clusters known as M6 and M7. Open star clusters are loosely bound groups of a few thousand stars, which were all originally formed from the same molecular gas and dust cloud at the same time, but are not as densely bound as globular clusters. Open clusters generally survive for a few 100 million years, with the most massive ones surviving for maybe a few billion years. Now, in contrast, the far more massive globular clusters exert far stronger gravitational attraction on their members, which is why they can survive so much longer. M6, which is also known as the butterfly cluster, is some 12 light-years across and located about 1,600 light-years away. It contains around 80 stars, which are all less than 100 million years old, which is quite young in cosmic terms. The M7 or Ptolemy cluster is named after the famous Greek astronomer and mathematician Claudius Ptolemy. It's about 980 light-years away and is far more dispersed than M6, covering an area around 25 light-years across. And at around 200 million years, it's about twice as old. Born in the year 100, Ptolemy lived in Egypt while it was under Roman rule. He wrote over a dozen scientific treatises, the first of which was an astronomical work now known as the Almagest. While some of his works were very insightful, much of it was error-prone, and measurements were simply modified and changed to fit his theories. He's best known for refining a geometric theory for the universe, one which uses cycles and epicycles to place the Earth at the centre of the cosmos, with all the other bodies orbiting around it. Unlike most ancient Greek mathematicians, Ptolemy's writings never ceased to be copied and commented upon, both in late antiquity and in the Middle Ages. However, it's likely that only a few truly mastered the mathematics necessary to understand his works. That's evidenced by the many abridged and watered-down introductions to Ptolemy's astronomy that were popular amongst the Arabs and Byzantines alike. Galileo Galilei and Isaac Newton eventually overthrew his geocentric theory more than 1,000 years later. By the way, the M in terms like M4, M6 and M7 are abbreviations for Messier, in honour of the 18th century French astronomer Charles Messier, who developed an astronomical catalogue of fuzzy nebulous objects in the skies. See, Messier was a comet hunter, and he compiled a list of 103 fuzzy objects which weren't comets, and so from his perspective could be ignored. Later, other astronomers added additional celestial objects to the list, bringing the present catalogue up to 110. Our solar system, in fact most of the stars we see when we look up in the night sky, are located in the Milky Way galaxy's Orion Arm. The Orion Arm, also known as the Orion Spur or the Orion Cygnus Arm, depending on which name you prefer, is some 3,500 light-years wide and around 10,000 light-years long. The Orion Arm is named after the Orion constellation, which is one of the most prominent constellations in the Southern Hemisphere summer and Northern Hemisphere winter. Some of the brightest and most famous celestial objects in the constellation include Betelgeuse, Rigel, the stars of the Orion Belt, and the Orion Nebula, all located within the Orion Arm. The Orion Arm is located between the Carina-Sagittarius Arm, which is more towards the galactic centre from our position, and the Perseus Arm, which is more towards the outer edge of the galaxy from our point of view. The Perseus Arm is one of the two major arms of the Milky Way, the other being the Scutum Centaurus Arm. Long thought of as a minor structure, a spur if you will, between the two longer adjacent arms, Perseus and Carina-Sagittarius, evidence was presented in mid-2013 that the Orion Arm might actually be a branch of the Perseus Arm, or possibly a completely independent arm segment itself. Within the Orion Arm, our solar system, the Sun, the Earth and all the other planets we know, are located close to the inner rim in what's known as the local bubble, about halfway along the Orion Arm's length, approximately 26,000 light-years from the galactic centre. The local bubble is a cavity in the interstellar medium in the Orion Arm, containing among other things the local interstellar cloud which contains our solar system, and the G-cloud. It's at least 300 light-years across, and it has a neutral hydrogen density of just 0.05 atoms per cubic centimetre. That's just 1/10 of the average for the interstellar medium across the Milky Way, and about 1/6 that of the local interstellar cloud. The hot diffuse gas in the local bubble emits X-rays and is the result of a supernova that exploded sometime during the past 10 to 20 million years. It was once thought that the most likely candidate for the remains of this supernova was Geminga, a pulsar in the constellation Gemini. However, later it was suggested that multiple supernovae in a subgroup B1 of the Pleiades moving group was more likely responsible, becoming a remnant supershell. Our solar system has been travelling through this region of space occupied by the local bubble for the last 5 to 10 million years. Its current location is in what's known as the local interstellar cloud, a minor region of slightly denser material within the bubble. The cloud formed when the local bubble and another bubble called the Loop 1 bubble met. Gas within the local interstellar cloud has a density of about 0.3 atoms per cubic centimetre. From what we can tell, the local bubble isn't spherical, but seems to be narrower in the galactic plane, becoming somewhat egg-shaped or elliptical, and may even become wider above and below the galactic plane, becoming shaped more like an hourglass. And it's not alone, it's abutting other bubbles of lesser dense interstellar medium, including the Loop 1 bubble. The Loop 1 bubble was created by supernovae and stellar winds in the Scorpius-Centaurus Association some 500 light-years from the Sun. The Loop 1 bubble also contains the star Antares that we spoke about earlier. Astronomers have identified several, well, I guess you'd call them tunnels, which connect the cavities of the local bubble with that of the Loop 1 bubble. Collectively, they've been referred to as the Lupus Tunnel. Other bubbles which are adjacent to our local bubble are known as the Loop 2 bubble and the Loop 3 bubble. Looks like astronomers still have a problem when it comes to thinking up cool names. Also visible this month is the Eta-Aquarids meteor shower, which is generated as the Earth passes through the dust and debris trail left behind by Halley's Comet. Comet P1 Halley is a well-known short-period comet which visits the inner solar system every 75 to 76 years. The 15-kilometre wide mountain of rock and ice will make its next close-up appearance in 2061. It's named in honour of the British astronomer Edmund Halley, who in 1705, after examining ancient Chinese, Babylonian and medieval European records, successfully predicted its return in 1758. However, he died in 1742, before his prediction could be confirmed. The comet's highly elliptical and elongated orbit takes it from between the orbits of Mercury and Venus out almost as far as the orbit of Pluto. Halley's orbit is in retrograde, meaning it orbits the Sun in the opposite direction to the planets, that is, clockwise from above the Sun's northern pole. This retrograde orbit results in it having one of the highest velocities relative to the Earth of any object in the solar system, travelling at some 70.56 kilometres per second, or if you prefer, 254,016 kilometres per hour. As well as the Eta-Aquarids meteor shower every May, Halley's Comet also produces the Orionids meteor shower in late October. Astronomers think Comet Halley was originally a long-period comet which took thousands of years to travel to the inner solar system from the Oort cloud, but was gravitationally perturbed into its current orbit by close encounters with the giant outer planets. The Oort cloud is a hypothetical sphere of comets and asteroids beyond the heliosphere, a mixture of vagabonds from the solar system and objects from deep space which have been collected by the Sun's gravitational pull. Occasionally, as the Sun passes by another star, an Oort cloud object will get perturbed and be flung towards the inner solar system. The Eta-Aquarids meteor shower runs from the 19th of April through to the 28th of May, peaking around May the 5th, with around 55 meteors an hour, making it one of the Southern Hemisphere's best celestial showers. However, back in 1975, they were running 95 meteors an hour, and in 1980 it was up to 110. Even better, the bright yellow meteors often appear as streaks known as trains. As their name suggests, they radiate out from the direction of the constellation Aquarius and the star Eta-Aquarii. Just look towards the east after midnight and before dawn for the best view. Jonathan Nally is the editor of Australian Sky and Telescope magazine. He joins us now for the rest of our tour of the May night skies on Skywatch.
G'day, Stuart. Yeah, well, it's May now, so if you're lucky enough to have some nice dark skies where you live, if you go out in the early evening, you'll see the Milky Way stretching all the way across the sky from the southeast to the northwest. It's really quite a specky sight if you can see it under dark skies with dark adapted eyes. That's how galaxies seem from the inside. It's just absolutely glorious. The brightest star in the night sky, Sirius, can be seen during May about halfway up from the western horizon. So if you look out to the west and you go halfway up the sky from the horizon to overhead, you'll see this big bright star, and that's Sirius, the brightest star in the night sky. A little bit further sort of down to the south, there's another bright star. It's the second brightest star in the night sky. That's called Canopus. And low down on the western horizon, you can still make out the shape of the constellation Orion above the trees or houses, whatever are on the horizon where you live. It's still there for only a few more weeks, really. It's getting very, very low now. It's making its last appearance before disappearing from view for the next 6 months or so. Way down in the deep south of the sky, we've got the famous Southern Cross, of course, which at this time of the year is nice and high and it's standing upright. So it looks like a sort of a kite shape, a very small kite shape. To its left, you see two bright stars in the constellation Centaurus. Astronomers call them the two pointers because if you draw a line through them, it sort of points towards the Southern Cross. The two pointers are known as Alpha and Beta Centauri. And if you look at Alpha through a telescope, you'll actually see that it's two stars. And there's a third star as well that's some distance away and too faint to be seen through sort of normal backyard telescopes. It's called Proxima Centauri, and Proxima Centauri is actually the closest star to our solar system. It's a small star, it's very dim, so you really need to know where to look for it, and you need to have a big enough telescope. But if you just look towards Alpha Centauri, it's roughly there. So you're looking towards the closest star system to our star system. To the right of the Southern Cross, we've got the constellations Carina, Vela, and Puppis, which is some of my favourite area of the sky. It's just wonderful. You get a pair of binoculars under this and just sweep through this area. There are star clusters and nebulae and things. It's just glorious because it's in the Milky Way, and so there's lots of stuff to see.
That used to be a single constellation once, didn't it?
Yeah. It was a big constellation called Argo Navis, the ship of the Argonauts, and got split up. And the three main constellations it got split into are Carina, Vela, and Puppis. Puppis is the poop deck, Carina is the keel, and Vela is the sails. And there was a fourth constellation as well. It's just nearby called Pyxis. That's the compass. Would have been a big constellation. I mean, these things look nothing like a ship. Nothing like a sail or a poop deck or whatever. It's just that people decided to put their favourite ideas or mythologies or characters or whatever into the sky, so they made up their own join the dots affairs. You would not go out and look in the sky and think, oh, look, there's a big ship, with the sails and everything. So don't get fooled. Don't go out thinking you're going to see something like that. Now, down in this area of the sky, if you have dark enough skies and you've got your eyes dark adapted, you should be able to spot something called the Omega Centauri star cluster, which has about 10 million stars in it, and it's about 17,000 light years away. And there's also a galaxy down this part of the world too, or that part of the sky, I should say, called NGC 5128. You often hear it called Centaurus A. It's about 10 to 15 million light years away, and it's a huge galaxy. But both of these things don't look like that to the naked eye, but you can just make them out as a little fuzzy dot. Looks like a star that's a bit fuzzy, and if you get some binoculars onto them, it really looks like a fuzzy star, each of these things. And if you get a telescope onto Omega Centauri or Centaurus A, they really look quite tremendous. They're really, really impressive things. So you can actually see these things with the naked eye just as little tiny fuzzy blobs. They may not look impressive, but when you look at a picture of what they really are and think, wow, my eyes are actually seeing these things from 10 million light years away. That's really quite
a huge black hole in Centaurus A too, because it's one of the biggest radio sources in the sky.
Yeah, look, that's why I called it NGC 5128 when I initially spoke about it, because that's its catalogue name. Pretty much everyone calls it Centaurus A these days, but Centaurus A really refers to the radio source that is inside, and you say the black hole, because in the very early days of radio astronomy, when astronomers were pointing these radio telescopes around the sky, they would find these big sources of radio waves, and they didn't really know what they were. They could pinpoint them. It was pretty obvious that it was coming from this galaxy in this instance, but they didn't really know what was producing these radio waves. So there's Sagittarius A, and there's Cassiopeia A, and there's Centaurus A. There's quite a few of them like that. And as they found other ones in those constellations, they call them B, C, whatever. So, yeah, it's an impressive galaxy, that. And when you look at a picture taken with a big telescope or even amateur telescopes these days, it's a weird-looking galaxy, a strange-looking thing with this big dust lane going through the middle of it, or rather around the outskirts of it. So this is why I say when you go outside, and if you get a star map and you can actually spot this thing with the naked eye, it's just a little fuzzy blob, no brighter than a star. It doesn't look impressive that way, but when you think that you are actually seeing this galaxy from 10 or more million light years away with your eyes, and that the light that's coming into your eyes right now left there 10 million years ago, it's really quite incredible to it puts space into perspective. I've talked about Proxima Centauri, that the closest star to Earth a few moments ago. That's only just over 4 light years away. Centaurus A is over 10 million light years away. So that's the sort of difference you can see just with the naked eye. It's incredible. Anyhow, moving on, we've got the northern half of the sky. We're moving up to the north now. The northern half of the sky from our part of the world doesn't really seem to have many bright star fields at this time of year, at least during the evening. There are some famous constellations there that you can see, such as Leo, Cancer, and Virgo. Leo looks quite good. Virgo is just this big sort of seemingly empty space. But astronomers, amateur astronomers, love Virgo because when you get a telescope out and have a look into that part of space, there are actually lots and lots of galaxies. They're too faint to be seen with the naked eye, but a telescope can pick them up, and you're a huge galaxy cluster in the constellation Virgo, but you do need a telescope to see them. But if you wait till after midnight, you're going to get some spectacular constellations coming up at this time of the year, rising over the eastern horizon, and I'm talking Sagittarius, I'm talking Scorpius, which most people know as Scorpio, and most people have heard of those two constellations. And there's another couple called Scutum and Ophiuchus, which most people haven't heard of. But that part of the Milky Way region that these constellations are in is amazing. It's a bit like I was talking earlier about Puppis and Vela and Carina. Lots of things to see. Well, Sagittarius and Scorpius, so many things to see. Star clusters of various kinds and nebulae and dark nebulae and star fields and things. It's just really tremendous. Even just binoculars are good enough if you've got dark skies to spend hours just looking around that part of the sky. It really is incredible. And, that's one of the reasons why astronomy is so big in the Southern Hemisphere and why radio astronomy in particular has been big here, is because we get a good view down here of the Sagittarius region, which is towards the centre of our galaxy. When you look towards Sagittarius, you're looking towards the centre of our galaxy. So you're looking right into the middle of the city of stars that we live in, our galaxy, right? So there's lots of things happening there and lots of things for astronomers to study. Now, let's see what's happening with the planets at the moment for this month. Venus is the main attraction at the moment. It's nice and bright in the northwestern sky after sunset. You really can't miss it. It's because it's just big and bright. Mars is a little bit higher than Venus and a little bit further around to the north. It's not as bright as Venus. It just looks like sort of a medium brightness, orangey red sort of star. But if you take a look each night after sunset during this month, you'll see that those two planets are seeming to move towards each other. So the gap between them is narrowing down. They're not actually doing that in space, of course. It's just a line of sight effect from our vantage point here on Earth. But by the end of June, they're going to be right up close to each other, they are. So as the next 4, 5, 6, 7 weeks go, they're going to sort of slowly come together in the western sky. And at the end of June, they'll be right close to each other, which should make for a really, really good view. In this month, if you go out on the 25th of May, you'll see that Venus and the Moon and Mars will all be roughly in a straight line with the Moon in between. So you've got Venus, the Moon and Mars. That'll be an easy way to identify those two planets if you're having any trouble, because you go out and see the Moon, and you say, right, well, that bright star just below it, or that star in inverted commas, the bright star below it is the planet Venus, and that orangey red star just above and to the right, that's actually the planet Mars. So go out on the 25th if you can, if you've got good weather, and have a look, and you'll be able to spot them quite easily. The other two main planets that are easy to see, Jupiter and Saturn, well, they can be found in the early morning sky, so you're going to have to get up early. At the start of May, Saturn is rising over the eastern horizon just after midnight, and then it's visible for the rest of the night through till sunrise. Jupiter is coming up at about 4 a.m. at the moment. So you've got to be really a night owl or an early bird, at least to see it coming up over the horizon. If you're getting up at 6 o'clock in the morning or something, that Jupiter will be some distance above the horizon. And you can't miss Jupiter either, because it's nice and big and bright. And if you're awake in the early hours of the morning on the 14th of May, take a look outside and you'll see the Moon and Saturn very close to each other. So if you're having trouble figuring out which one of those things is Saturn, get outside early hours of May the 14th and you'll see that bright-looking thing just next to the Moon is Saturn. And similarly, on the 18th, the Moon will have moved a little bit further along in its orbit, and then you'll have the Moon next to Jupiter. So if you don't know which one Jupiter is, have a look in the early morning hours of the 18th and look for the Moon, and the bright thing right next to it will be Jupiter. And that, Stuart, is the sky for this month.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
We all know a guy who only occasionally shaves for big occasions, and it's because that occasional shave really hurts. It's the time of year for big occasions, and yet there he is, suffering with that cheap drugstore razor. Let's help him out. Henson Shaving's line of razors, built with aerospace precision, deliver a smooth shave your dad, brother, and even son can enjoy, eventually. With replacement blades just 10 cents each, you'll buy it once and they'll use it for life. How's that for the perfect gift? Celebrate with 100 free blades on your first purchase, and no subscription headaches. HensonShaving.com/holiday.
Feel the whoa with Listerine at BJ's. You can save $2.50 now on Listerine products like Total Care Anti-Cavity Fluoride Fresh Mint Mouthwash or Cool Mint Pocket Packs Fresh Breath Strips at your nearest BJ's location. Experience the feeling of a million germs zapped in seconds with Listerine. Discount available through December 24th. Save now only at BJ's.